Good afternoon, everyone. We'll just start in a couple of minutes. Let's just wait for a couple of minutes and then we can start. Yeah, I think we should start. Let me just first confirm. Can someone please confirm? Am I audible and is my screen visible? Yeah, thank you. So, due to some bandwidth issues, actually, I'm not in campus right now. So, I haven't connected my camera. Sorry about that. So, let me give my introduction. We are bound to do this every time. So, my name is Musa Rafiq. I'm the course TA for course Digital Circuits. This is live session number 10. The course instructor is Professor Shantanu Chattopadhyay. Uh, I'm a PhD student in the Department of Electrical Engineering at IIT Kanpur. We carry out this TA work as part of PMRF deliverables. So every week we meet from 3 p.m. to 5 p.m. to discuss problems pertaining to that week's uh, that week's content. And also, let me just give some instructions as well. So you are required to keep your cameras and microphones off. And if you have any doubt anytime, you can always use the chat box. And if you want, you can always unmute yourself and ask the doubt. I typically give some time after the problem is solved. And this week we are going to discuss problems related to hardware description language, some basic problems. And these are mostly theoretical ones, so I need your participation, I think, for almost all questions. Otherwise, it becomes too obvious. And one more thing, so this is live session number 10. After that, you have two more live sessions, that is live session number 11 and live session number 12. And then you'll have one more live session, that is the recap session. That details will be shared with you by NPTEL team very soon, and that will be after the 12th live session. That will be before your exams. If anyone is appearing for exams, that will be before that. So, is it so? Is my screen not visible? Anyone else? I think it should be visible. From my end, it's showing visible. Yeah, it's visible. It's visible. Kindly reconnect. Leave the meeting and join again. I think it's visible for all others. Yeah. So, anything else? I think, yeah. So I think we can proceed. So let's just wait for the guy to join. Let's just wait for the student to join, and then I think we can start. Or maybe we can start, yeah. And also one more announcement. I think you people are aware of that. These live sessions are being recorded and are uploaded to the YouTube, and the link to that live session will be shared on the same drive, Google Sheet that is available to you guys. So first question: which of the following statement, sorry, which of the following statement is true? Option A: SGLs and computer programming languages are similar. SGLs describe hardware rather than executing a program on a computer. Option C: SGLs describe software and not hardware. Option D: computer programming languages describe the hardware. Anyone would like to point out the correct answer can write in the chat box. So what will be the correct option? Anyone? Thank you. Yes, as rightly said by one of the participants, it's option B. So HDL stands for Hardware Description Languages. They are used to model, design, and simulate electronic systems, in particular digital circuits. So there are two very famous hardware description languages. Can you name them? So let me just tell you. Yes, Verilog. There are two famous HDL. Number one is Verilog, and number two is VHDL. In today's live session, I have some problems, some code snippets, and some complete codes related to VHDL. We'll see that thing in detail. And regarding the question number one, option B, as rightly said by one of the participants, is the correct answer. So hardware description languages, or HDLs, are used to model, design, and simulate electronic systems, in particular digital circuits. Now, coming to option question number two of today's live session. Just a second, and let me make it a slight bigger. Why not option D? Program languages are written for programs, for softwares. They are not written for hardware. They do not model or design these systems. Hardware languages are in particular written for these to mimic, to model the digital systems, right? So number two, which of the following is the basic building block of a design? Option A, architecture. Option B, entity. Option C, process. And option D, package. Anyone? What will be the correct answer? When we talk about design, I'm talking from a digital design perspective. That is the hardware description language point of view. So, what is the basic building block of a design? It's option B, as written by some of the students. It's entity. So you can imagine entities as some kind of a black box, and you have your inputs and you have your outputs. This entity links your inputs and outputs. And now in the next slide, I think I have one code snippet that is of entity, right? This is a syntax of for the entity in VHDL. You see here this thing. This is a keyword for entity, which means entity block gets triggered by this keyword. So this is your keyword for entity. This right here, this is my underscore entity. This is your entity name, right? It can be user defined, or I should write it is user defined. Then again, this is your keyword. Then inside entity you have this port with parentheses. This port is again a keyword wherein your input output declarations are given, right? Inside port are port declarations given, the port direction, port type, and all, which are given inside the this port declaration. And here you have this first thing, which is your input port 1. This is again user defined. This in underscore port 1 is user defined input port. And how I am saying this is input? By looking at this keyword which specifies the direction. This is a keyword which specifies the direction, whether it's an input or output. So this input underscore port is your input name. Then is the colon, that is part of your syntax. Then in, that is the keyword direction. And this is your std logic, which tells you the type of port type. And also this std underscore logic specifies it is a 1-bit input. Similarly, we have another input underscore port 2, which is your another input, then followed by the colon, that is part of your syntax, then the input which specifies the direction, that is its input. Std underscore logic is again, it comes from the IEEE package and IEEE library, and it's a 1-bit data type. Then you have your two outputs. So you can imagine this as your two inputs, and these are your two outputs. And you have your two outputs as output underscore port 1, output underscore port 2, followed by the colon, then out specifying the direction, and this is your std logic which specifies it's a 1-bit data type. And then you have to end this, you have to close this entity. So the keyword for closing is end. keyword for termination. And here you have to write entity name. One more thing, this entity name is similar to this. And VHDL I think is case sensitive. Can someone confirm? I think it's case sensitive, so it needs to be in same cases whatever you have defined here. I'll repeat again. This was the code snippet for the syntax showing entity, syntax for entity block, which is a basic building block of your design. You have the keyword entity here, followed by your entity name, which is user defined, followed by another keyword that is. Then you have port declaration triggered by the keyword port, inside which port, number of ports, number of direction of ports, port type is defined. You have your first input port, that is input underscore port 1, and another input, that is input underscore in underscore port 2, followed by the colon. Then the direction, here the keyword in specifies these are inputs, then followed by the data type, which is specified as std underscore log, that is taken from IEEE library, which is a 1-bit data type. Similarly for output, everything remains same apart from the direction of the signal. And ultimately you have to terminate it with the keyword end, right, followed by the entity name, which is similar to this. Now so far we have solved two questions. I think we can move forward to question number 3 of today's live session. So this states that Intel 8086 is a dash processor. Option A 8-bit, option B 16-bit, option C 32-bit, and option 4 64-bit. Can anyone tell me? Yes, thank you for your responses. It's option B 16-bit. So what do we really mean by the 16 bits? So when we talk about the 16-bit processor, it means data and your register size, data and your register size is 16 bits. And also when we talk about this number of bits, it specifies that number of bits that can be processed or manipulated by a process at the same time. By the way, what is the size of 8085? It is a 8-bit, correct. So one more thing I'll announce here. So for next two live sessions, that is 11 and 12, we will discuss problems pertaining to microprocessor only. So there we will thoroughly discuss microprocessor and their architecture, their working, and some coding problems as well. So those will be discussed deeply in next two live sessions. Now question 4, I would like you guys to answer first, and then I'll show you the solution. Which of, I think it's a direct statement question. So which of the following is not an EDA tool? Option A Verilog SDL, option B VHDL, option C Xilinx ISC, option D Visual C++. Nice, really nice from you guys. So you have already answered it correctly. So it is option D, which is not an EDA tool. So Visual C++ is not an EDA tool. Verilog HDL is an hardware description language, as we have seen earlier, and also VHDL is a hardware description language. Xilinx ISC is a dedicated software. It was a software tool basically from Xilinx, which was used for synthesis and analysis of HDL designs. I think it's outdated now. So, as you rightly point out, it's the option D, which is the correct answer. Now, question number 5 of today's live session is logic synthesis is the process of dash option A converting behavior level description to structural level netlist. Option B, converting structural level netlist to behavior level description. Option C, converting high level language to machine level language. Option D, converting behavior level description to architecture level. So the correct answer to this question is option A, that is converting behavior level description to structural level netlist. Now we have question number 6 of today's live session. which states that which of the following is the default type of ports of an entity. It says that which of the following is the default type of ports of an entity? A. Variables, B. Constants, C. Signals, D. Functions. Anyone? The correct answer to this question is signals, option C. So basically input and output signals, they are taken by default are taken as signals. So in an entity, when we define question number 5. Just a second. So let me just go briefly over question number 6. So which of the following is default type of ports of an entity is signal. So by default, when we define the input output ports, they are taken to be signal by default. So question 5 asks us, logic synthesis is the process of A. Converting behavioral description to structural and netlist. B. Converting structural and netlist to behavioral description. C. Converting a high-level language to machine-level language. Option D. Converting behavioral description to architectural description. Its the correct answer is converting behavioral description to structural level netlist. You can refer to your notes if you are having any doubts here. Basically, you can say that when we talk about logic synthesis, it is the process of converting an abstract specification of circuits behavior into a design that can be implemented. Right. So for the more details about this, you can always refer to your lecture notes. Then question number 7. Can anyone tell me what is the answer to this? Microprocessor contains option A, ALU memory input output, option B, ALU control circuits and register circuits, option C, CPU memory and input output, option D, CPU input output only. I see some of the students have typed their answers. It's option B as rightly written out by the students, which is ALU, arithmetic logic unit, control circuits, and register circuits. As I already said earlier, we'll discuss microprocessor in detail in next two live sessions. That is live session number 11 and live session number 12. Just give me a moment. I'll bring some water. Actually, I'm having some coughing issues, so just give me a couple of minutes. I'll bring some water. Yeah, we can resume. So actually, I'm having dry throat. So now I think we are done with question number 7. So next is question number 8. So the following code snippet, basically this is a code snippet I have here. VHDL code snippet. It says that sum gets assigned to A XOR B, carry gets assigned to A and B, where your A and B are inputs. What does it represent? So anyone? What does this part represent? Yes, option A, and that is option 1, half adder. So you have your two inputs which will be declared in the entity block and your output sum and carry as your outputs. Sum is your basically A XOR B and carry is your A and B. So you have two signals A and B going to the XOR gate and producing the sum, and these two signals go to the AND gate where the carry is produced. So A, B, sum, and this is your carry 0 0 0 1 0 1 1 0 1 1 0 1 1 0 0 0 0 1. So next question, can you tell me in VHDL the assert statement is used for A. Declaring flip-flops, B. Reporting warnings and error messages during simulation of model, C. Synthesis of VHDL code, option 4. Place and route of design. Anyone? What is the correct answer to this question? So I will repeat questions for you guys again. And so question 9, it states that in VHDL assert statement is used for anyone. What will be the correct answer to this question? So the correct answer to this question is reporting warnings and error messages during simulation of model. So basically this what this assert does is it prints messages at the simulation console when when some specified runtime conditions are not met. So I repeat it again. Assert prints messages at the simulation console when specified runtime conditions are not met. There are four type of security levels, or you can say safety levels, security levels defined by assert. Number one is your note, NOTE. Number two is your warning. Number three is your what is your number three? Error. Yes, error is your number three. And number four finally is your failure. So what does this note mean? It relays information. It relays information for user about conditions, right? Warning, it relays information about conditions that are not expected and not fatal. Number four is error. Sorry, number three is error. It relays information that the model is going to work incorrectly. And finally, failure. It relays information about conditions that are catastrophic. So again, I'll tell you, in VHDL, alert statement is used for reporting warnings and error message during simulation of model. There are four types of security levels defined by alert. Number one is note, it relays information about the conditions. Number two is warming, it relays information about the conditions that are not expected and not fatal. Error is relays information about when the model is going to work incorrectly. Failure is it relays information that are catastrophic. Now, question number 10 is a statement type of question. So, can you just a second? So, how many type of shift operators are there in VHDL? Anyone? How many types of shift operators are there in VHDL? Anyone in the audience? So, answer to this question is six. There are six shift operators there in VHDL. What are those? Number one is your rotate left logic, also called as RLL. Number two is rotate right logic, RRL, or rotate right logic. Yes. Number three is your shift left logic, SLL. This is actually ROR and this is ROL. Number four is your shift right logic, that is RL, SL, SRL, yeah, SRL. Then your fifth is your shift arithmetic, sh- shift left arithmetic, SLA. And your sixth is shift right arithmetic, SRA. So there are these are your six shift operators in VHDL. Now I have question, that is question number 11. A package in a VHDL consists of commonly used architectures, commonly used tools, commonly used data types and subroutines, commonly used syntax and variables. Anyone? Think again, think again. I'll just repeat the question. A package. So you might people might have seen the VHDL codes, and you people have seen you import packages. Where do you use that? Just think about it. Do we use for syntax? Kindly check again. Those people writing option D. Do we really use for syntax and variables? So if we import some package, why do we import some package? So the correct answer to this question is option C. Commonly used data types and routines, subroutines. So what we have here is we first import library, and from library we import packages. So the packages give us the liberty to the programmers. They can, what should I say? They can use them in design without defining some functions again and again. So these subroutines can be thought of as functions. So you have done, let's say, programming or anything else. So if you want to use function, some block, some entity again and again, you define a function and call it. So this package can be thought of that way. So if you want to use some predefined functions, predefined subroutines, you'll call that package and use them. So this package is used so that the programmers can use them in design without defining same function again and again. So option C is data types and subroutines. So in the earlier at the start of this lecture, I defined a what should I say entity block, and there I had written std underscore logic, right? And you people might have seen in some codes as well. Have you seen entity underscore this std underscore logic before? Std underscore logic, right? Anyone? Have you seen that before? Have you seen that part? I'm talking about this one. Maybe I'll just highlight this part. This thing, right? Subroutine is, you can say, if I want to give an analogy of subroutine, you can say it as a function. Like you have already some block, well-defined block that performs the given functionality. Then you have to call that block only. So let's say I have a function that gives the AND operation between the two variables. So, and I will call that function as AND. Now, what I will do when I am writing the main part, I'll just write y is equal to a and b. So this will automatically execute operation a and b. Got it? And this std underscore logic. Have you seen this? Can anyone tell me what is this? I have elaborated on this part at the start. Can anyone tell me what is this? What does this std underscore logic stand for, and what it does in the given block? Std underscore logic tells us about the data type, right? It's a 1-bit data type, right? But from where does it come from? To include this, you need to import something, right? Yes, from library. And from library you import, packages where you write use. You got it? That use statement. Whenever you import library, you do it in two lines typically. You can also do it more than two lines, but first thing is your library and second thing is your packages. So these are your data types, and there are also subroutines. I think you people got it right now. And now question number 12 of today's live session is, in VHDL, bus is a type of in VHDL, bus is a type of. The correct answer to this is question is option A, signal. So bus is a type of signal which may have its driver turned on. Now in the next slide, I have kept the code of AND gate in VHDL. So here I have this code, and I'll go line by line over this, and then I have some question after that for you guys. So the first line I am writing library IEEE semicolon. So this part, this specify is a keyword where we import the library, and this is the library name. Then this use is used for importing packages, and from IEEE we want to import packages std underscore logic underscore 1164. And which packages? All of the packages from this, all packages. Then I'm defining entity, so I'll have my inputs A and B of AND gate and output Y. One thing, you see, some of the part is in bold, some of the text is in bold. Bold specifies keywords. So what will trigger the entity block is the keyword entity. Then is this part which is nothing but your entity name, and how written is AND gate. This is my entity name. Then is the keyword is, and followed by the port keyword for port declaration. So here I have inputs A, input B. So A colon in specifies the direction of the signal. std underscore logic, I have taken it from here, which is the data type, which is a 1-bit data type, followed by semicolon. Then B colon in, that is again my input. std underscore logic specifying the direction of, sorry, the data type. Then I have my output Y followed by colon followed by out specifying the direction. Then std underscore logic specifying the data type. Also VHDL is case sensitive. I think I've already elaborated on that point. Then after that I'll have to terminate this entity by using the keyword end followed by entity name. See, this should be similar to this. Then comes the architecture, which is again triggered by the keyword architecture followed by user defined name. That is and logic I have done here. And logic is my, what is, should I say, this architecture name followed by keyword of. And then what is this architecture part of? This is part of the entity. Which entity? AND gate. Same name should be given here, right? Then the keyword is. Now after that I will have another keyword, that is begin, where I'll have this assignment operation. This assignment operation is done by this symbol less than equal to. So I'm assigning A and B to Y. So I'm assigning A and B to Y. Then I'm ending my architecture by keyword and I'll end it by writing the architecture name, that is AND logic followed by the semicolon. This was my syntax of an AND gate in VHDL. Now I have a question for you guys to solve. List every syntax mistakes in the following VHDL code of OR gate. So I'll suggest you go over this code line by line and list all the mistakes. It may not not all the lines may have mistakes, but you need to find out what are the mistakes. So it would be best if you go line by line and point out each mistake and try to send all of your mistakes in one message rather than going one after the other. So write a complete pair of mistakes and type it in the chat box. Anyone? So I see a couple of answers from the students. In fact, three. So let's just go by line by line. So first statement is library IEEE followed by semicolon. That is correct. So let's highlight mistakes in some different color. I think I should use red for mistakes. So next statement is use IEEE.std underscore logic underscore 1164 dot all. It should be terminated by semicolon, as someone is rightly pointed out. Then I have entity or gate is, so it's correct. So this is the or gate keyword. Then there is port, which specifies my port direction, port type, and data type. It's A followed by colon followed by in std underscore logic. B semicolon in under std underscore logic. Y out std underscore logic. So this part is correct. Then I'm ending OR gate. So OR gate should end with semicolon. So here it's colon, it should be semicolon. Then I have architecture followed by architecture name followed by entity name followed by is. So here it should be begin, and here assignment is of or, not of and, followed by semicolon. And is that it? Is there any other mistake? Is there any other mistake? There is one mistake. One mistake there is left. Can someone find it? One mistake is left in this snippet. Yes, at the end, this is the end of architecture, and here it should be architecture name, not the entity name. So it is OR underscore A. Got it? Now let's move forward to this block, which of the following is correctly declared library for VHDL code? So anyone, which is the currently written syntax for library? I'll again repeat, which of the following is correctly written declared library for VHDL code? It's option D. So your library is written in two lines. Your first library followed by library name, then your package which is triggered by use, followed by library dot package dot parts. Which part you want to import? Previously we imported all parts, so it's option D. That is correct. So this question, I think everyone will know the answer to it. What does VHDL stand for? Option A, very high speed integrated circuits. Option B, very hard description language. Option C, very high speed integrated circuits. Option D, Verilog HDL. VHDL stands for HDL. I think everyone will know it. HDL is your hardware description language, right? Now, what does V stand for? Right, that is your question. V stands for, which is in fact short for VHSIC. That is very high speed integrated circuits, and that is your option C. Very high speed integrated circuits hardware description language. That is the abbreviation of VHDL. VHDL, I think, was developed by Department of Defense of United States. You can always look up to that part. Now I have another question. This states that which of the following is the correct VHDL entity declaration of the block diagram given below? So below you have your block diagram, and you need to correctly mark the option which defines it. So, as rightly pointed out by most of the students, it's option C. So let's see what is the issue with other options. So your A and B are your inputs. So in option A, it defines P input as well. In option B, PQ are your outputs. A and B are your inputs. A, B. In option A, all of them is defined as inputs. In option B, A, B, and P are defined as inputs. When in reality, A and B are only my inputs. In option C, it defines A and B as outputs and PQR as inputs. Again, wrong. And option D, A, B, which is option C, which is correct. A, B is inputs, PQR is outputs. That is option C, rightly pointed out by you guys. Option 17, which of the following is not an application of VHDL? Design verification, design synthesis, model digital system, model analog systems. So the correct option to this question is option D, model analog system. So as I've said it earlier, these hardware description languages are used to model, design, and simulate electronic systems, and in particular digital systems. Now question 18. Which of the following is not defined by the entity? I think we have gone this entity block over many times. So can you tell me which of the following is not defined by an entity? Anyone else? Input output. So you definitely define direction in entity. Correct answer is option D. Declaration of ports is defined, name of signal is defined, direction of signal is also defined. It's option D, which is not defined in entity. Now question 19. Which of the following statement is true? Microprocessor contains memory to store program and data. Microcontroller does not have an on-chip memory. Microcontroller contains memory to store program and data. Option D. Microprocessor contains memory to store program. Which is the correct answer? I'll again repeat the question. Which of the following statement is true? Microprocessor contains memory to store program and data. Microcontroller does not have an on-chip memory. Microcontroller contains memory to store program and data. Option D. Microprocessor contains program and memory to store program. So the correct option as rightly pointed out by some students is option C. That is microcontroller contains memory to store program and data. Now question number 20 of today's live session. So you have this basic logic block described by the following VHDL code. So you have this block. You need to tell what does this do. I'll again repeat. Identify the logic block described by the following VHDL code. Can you tell me? I think all of you have given the correct answer. That is 2 is to 1 marks. So this is a code snippet that I had here. So this process is a keyword, and the parenthesis, whatever is inside the parenthesis of process, it means any change in any of those signals will execute this block, and this block is executed sequentially. Now there is begin, and I have if condition on S. So if S is 1, I'll get assigned, my output gets assigned A, else output gets assigned B, and then end if end process. So what it is, I have output Z, I have input signal A, I have input signal B, I have select line S. This is 0 and 1. So when S is equal to 0, output is A. When S equal to 1, output is B. That is Z is equal to S bar A plus S B, which is nothing but your 2 is to 1 mux. This part means any change in the following will trigger the following code block. Now this question is VHDL and Verilog are, I think everyone by now will tell the correct answer. Yes, exactly. So VHDL and Verilog are hardware description language. Now, towards the end of this live session, so far we have discussed the problems. These are mostly theoretical ones, mostly fill in the blanks type. And to give you some different flavor, I had kept some VHDL code snippets, gave you some idea about how to find error in the syntax and all. Now I have kept two complete code blocks written in VHDL for two well-known digital circuits to you guys. So one is 4:1 mux and another is D flip-flop. So what I will do is I'll go line by line to every part of those codes and briefly show you the VHDL code of this 4:1 mux, that is a combinational circuit, and D flip-flop, that is your sequential circuit. Now my first thing is 4:1 mux. So this is a 4:1 mux code for your in VHDL, right? First line is library IEEE. This is your keyword and this is your library name. Then here in these three lines I import packages. Here I import std underscore logic all, and these are your other two packages. You can refer to your lecture note or maybe use some other sources to get the details about these two, maybe for all. So I'll again repeat. First one is to import the library IEEE and then the packages. For the details about packages, you can always refer to your notes and or some other sources. I don't want to go into detail. Then I have entity, which is the basic building block of your design, which is triggered by the keyword entity, right? This is your keyword. Then your entity name, which is user defined. So here the entity name is deep un underscore mux underscore out. So this part is your entity name. And then you have the keyword is. Followed by the entity, we have the port declarations triggered by the keyword port. So for 4:1, how many inputs I'll have? For 4:1, how many inputs I will have? For 4:1 mux, how many input signals I'll have? You'll have four input signals, and there will be also input signals, which is the four are your input signals, input data, and there are some other input signals as well. Correct. You have select lines as well. So input one, then followed by colon, followed by input that tells you about the direction of input. Then std underscore logic, right? And what is this part? This thing, one that I've highlighted. Can you tell me? Yes, this is the comment. Uh, so it is that part of the code that is not executed, right? Then you have input 2, followed by colon, followed by direction, followed by std underscore logic, that is the 1-bit data type. Input 3, followed by colon, followed by input underscore std underscore logic, then input 4. Then I have select line. For that I have SEL, followed by colon, followed by input direction, then std underscore logic underscore vector. So std underscore logic underscore vector gives you the array. It is basically array of std underscore logic values. Basically, it is an array of logic values of std underscore logic values, and it is a 2-bit data type. How can you tell me how it's 2-bit data type? How I identified that it's 2-bit data type? No, from code. How I identified it's 2-bit data type? Yes, exactly. 1 down to 0, it tells me that it's a 2-bit data type. Basically, when we talk about this std underscore logic underscore vector, it allows us to represent multi-bit data signals, right? So it's again an input data type, 1 down to 0, where the first one represents your MSB and the second one represents your LSB. Then I have data out, which represents my output. So I have something like this: two select lines, S1, S2, then four inputs, so I1, I2, I3, I4, and one output, that is data out. IN1, IN2, IN3, IN4, which is the output, steady underscore logic. Then I have ending my entity, followed by, what is this? I am ending my entity with what name? Entity is end by using keyword and, followed by, yes, followed by entity name, which is user defined as I have defined it here. Then I have architecture, which is triggered by the keyword architecture, followed by behavioral, which is nothing but your architecture name, followed by of another keyword, followed by this thing, which is your entity name, followed by is. Then I have begin, and here I have written comments, which is this is process for mux logic. Then I have written process, followed by select input 1, input 2, input 3, input 4 in select parentheses, which means any change in any of those signals will trigger the following block in sequential manner. Then followed by begin. Then I have used this case on the select line. So basically I'm evaluating based on the combination of select lines. So it states that when select line is 0 0, assign input 1 to my data. When select line is 0 1, assign input 2 to my data out. When select line is 1 0, assign input 3 to my data out. When it's 1 1, assign input 4 to my data out. And when other case, assign 0 to data out. Then I'm ending case, and then I'm ending process, and then I'm ending architecture with the architecture name. So this was the code for 4 is to 1 mux. We have gone over it line by line. Now we'll go over the VHDL code for D flip-flop. Again, I'll have the first line for library. Here I introduce library IEEE, followed by the packages, then entity, which is the keyword for entity, followed by D flip-flop 1, which is your just give me a second. I think something happened. Yeah, it's visible now. Yeah, entity followed by entity name. So here I have given the name dff1 followed by another keyword is. Then I have the port declaration. So d comma reset. So reset, for reset I have in short written res comma clock colon are your input data types are your inputs with data type std underscore logic, that is 1 bit data type. So but it's another way of writing the inputs. So I have combined different inputs d reset clock together in one line, and I have written that all of these signals are inputs and 1 bit data type. Then q is my output, is again 1 bit data type. And then I'm ending my entity by writing and with the entity name dff1. So this is the entity block. So for d flip flop, q is equal to d, right? Then I am starting my architecture, followed by the architecture name, that is the behavioral, which is the architecture name. I should write it here. Followed by the entity name, followed by is. Then it's begin. Then it's process clock. Any change in the clock. So this is a port declaration. So someone has written, can you please explain second line of entity block? So port declaration. Previously, all my inputs I had written in separate lines, input 1, input 2, and so on. But here I have combined them into one single line, port. That is your, so basically D flip-flop will have this clock as input, this D as input, and the reset signal as input. So D, clock, and reset are your 1-bit data types signals, and I have combined them in one line. Got it? Now there is output and so on. Finally, we have a process clock. Any change in the clocks will trigger the following process, this snippet. Then I have begin. So it states that if reset equal to 1, then Q gets assigned to 0. So if my reset signal is high, my Q will be equal to 0. Else if clock underscore clock apostrophe event and clock equal to 1. Anyone can explain me what is this block? What do I mean by this? Else if clock apostrophe event and clock equal to 1. What does it mean? So else if clock event and clock equal to 1. What does it mean? No, that part is true. Both I am using and condition, so both the conditions should be true. Then the following will execute. But what does this statement together mean? Else if clock event and clock equal to 1. Basically, you're right if both conditions are true. But when are the both conditions true? What is happening there? When both conditions are true, what is happening? What does it specify? No, no, that's fine. Reset equal to 0, fine. But this combination, clock event and clock equal to 1 together specifies a certain condition. Think about it. I want you guys to tell me the answer. I won't go further until I have the answer. Clock equal to Q doesn't make any sense. Can you think somewhat different? You all people know it, but just think about it. Clock equal to 1, I think all of you know it. What does the clock equal to 1 mean? Clock event means when I'm talking about clock event means any change in the clock. So if it was 1, it becomes 0. If it was 0, if it became 1, it means clock event. So it is true. When there is a change in the clock value, a clock event will be going to 1. Now tell me, what is this clock equal to 1 and clock equal to 1 specifying? Okay, let me give you one major hint. I think after that all of you will be able to tell me the correct answer. Clock apostrophe event is equal to 1 whenever there is a change in the clock signal. Clock apostrophe event is equal to 1 whenever there is a change in the clock signal. Now tell me, what is the statement telling us? So first condition tells us whenever there is a change in clock signal, it can go from 0 to 1 or 1 to 0. Now combined with clock equal to 1, what does this tell us? And clock equal to 1. Clock event and clock equal to 1. I think this has something related to clock, right? You should be able to realize it. What does this condition mean? Clock goes high. And what do we call that? When clock goes high, we have a particular name about that. You're right, clock goes high. That is the correct answer, but we have some particular name associated to it. No, 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 no. I think now all of you will tell it the correct answer. Yes, positive edge. Positive edge triggered flip flop. So this condition was meant for positive edge triggering. So whenever there is a change in clock signal, this clock event is 1. So I'm going from 0 to 1 or 1 to 0. It will be 1 in both cases. But if it's 1 and it's 1, it means I am going to a positive edge triggering, right? Then, so at positive edge triggering, Q equal to D. Assign D to Q. And if and process and architecture by writing the behavioral and behavior, which is the architecture name. So this whole thing was your D flip-flop VHDL code. I think that was all for today's live session. If you have any doubts, please let me know. Otherwise, we can meet next Sunday, that is 6th of October. We are really discussing microprocessor, and the next lecture following that, that is on 13th of October, we'll again discuss microprocessor. So last two lectures will be related to a microprocessor, and I think on 20th October I have given my slot to NPTEL team, but that is subject to their approval. So most probably it will be on a recap session will be on 20th October at the same time. Any doubts? Please let me know. Otherwise, we can close this live session. Okay. Thanks for the feedback. We can meet next time.